Uh, hello. My project topic name is Design and Analysis of Pressure Vessel with Counterflow Limpet System for a Variable Thermal Load. My name is Shukla Vivek Kumar. Now, moving to my topic. First of all, this project of my stage 2 of my project is related to industry, and this project is being done in an industry called as MDP Solutions Private Limited, located at Kandivali. Now, these are the contents of my topic, which is already I have discussed in the stage one. Now, as we know, pressure vessel is used for handling the pressurized fluid, which is either applying internal or external type of pressure by the source. Always, some of the pressure vessels are used for heating or cooling type of operation. Also, there are various operations such as reaction, distillation, boiling, condensation, heat transfer, crystallization, flashing, etc., being carried out in a various type of pressure vessels. There are three types mostly which are used: horizontal, cylindrical, and spherical. Now, what are the properties of material which are required for construction of the pressure vessel? So, obviously, most of the mechanical properties will be discussed or handled, such as tensile strength, elastic limit, modulus of elasticity, endurance, resilience, toughness, ductility, brittleness, and hardness. So, every pressure vessel before manufacturing, the material which is being used will be always tested. If there is something here and there found, or the properties of the material are not up to the mark, then the material will be rejected, which cannot be used for the further manufacturing process. These are the various type of codes which are used in the manufacturing of pressure vessel. Most of the favorite code are American codes. So American ASME Section 8 Division 1 is the most favorite code used by the most of the industry, and across the world many clients recommend the same code. Now there will be always an exchange of a data. As we all know, pressure vessel is a part of any process. So process engineer who are from the chemical domain will be designing the process. And most of the mechanical design of any type of pressure vessel is done by the mechanical engineers. Now I am working for the MDP Solutions, which is a kind of a consultancy located in Mumbai, and they are designing this particular pressure vessel handling ethylene oxide as a fluid. Now, what are the parameters which are considered in a mechanical design? That is nothing but the shape of the pressure vessel, location or position of the pressure vessel, horizontal or vertical, which type of fluid it is handling, and what are the design parameters such as temperature as well as pressure. Then overview of pressure vessel. So there will be always things will be discussed based on the operating conditions such as temperature, pressure, what is the volume, capacity of the pressure vessel, mostly the percentage filling means how much percentage of pressure vessel will be filled. We never filled it 100%, so it will be always 80 to 90%. Water capacity is almost the same. And what are the type of fluid which are using, whether it is corrosive, hazardous, abrasive, or lethal. Then required MOC stands for material of construction. Type of ends, whether it is elliptical, hemispherical, toruspherical, flat, etc. And the nozzle schedule. So what is the size of the nozzle? So nozzles are mostly used to take in and out the material inside the pressure vessel. Mostly corrosion allowance is being used when the material is corrosive in nature. So that we have to always consider in a design. And the preferred code. So code is being designed or mutually decided between the client and designer almost, and then it is being conveyed to the fabricator, and the material will be tested, which is being used before any type of manufacturing. Then various type of components of pressure vessel as we discussed. There is a shell part, head part, various type of nozzles which are used. Then there are various type of supports such as saddle support. As you can see at the bottom of the pressure vessel, this is a saddle support. There is a skirt support which is mostly used in a vertical long columns. Leg support and lug support are used for the pressure vessel who is standing on the ground or supported in between the two floors. These are the various papers. I have almost seen 8 to 9 papers, and the summary is being mentioned. This is the abstract of my project. Now, what is the aim? So, I am going to design a pressure vessel and check for the analysis, and the data will be conveyed to the industry, which is handling the limpet system. The counter flow is not a part of this particular design, but I am introducing this counter flow because in this particular pressure vessel, the timing for the cooling down is essential, and I have to reduce that particular timing of the cooling based on the thermal analysis of the pressure vessel. Following out the objectives, obviously, so design of the pressure vessel with the limpet system, satisfying the ASME standards codes. Validation of the design will be done by the code. MOS, that is material of, MOC, material of construction for the limpet system being analyzed. And the limpet system will be checked theoretically and experimentally also. So this is something like a lug and leg type of support. Also, there is a limpet of the on the periphery of the pressure vessel is shown. This limpet is nothing but the pipe which is being cut in a, you can say, two parts, and it is like a half of the pipe being welded throughout the periphery of the pressure vessel. This is my project methodology, in which the data will be taken from the industry, and on that data I'm working with their team. So we are doing the analysis, thermal analysis in the is will be the latter part. Now we are going stage wise, so there will be modeling will be done. So here, if you can see that there is a basic engineering package, the data which is I am getting from the industry. It will have a design parameters such as temperature, pressure, operating condition for the pressure vessel. Also the code and the guidelines which are given. Mostly the design has been given by the code, so all the formulas related to design of the pressure vessel are mentioned in that. Then material selection is also important. If the material fails, I have to again go back to the basic engineering package and I have to discuss with the chemical engineers. If it passes, I have to go for further 3D modeling and analysis of the pressure vessel along with the limpet system. Now, if the analysis, post analysis, if the results are okay, I will recommend that particular pressure vessel for the fabrication. If it is not, I will go back again and change the design parameters up to certain level. So this is how the limpet type pressure vessel mostly seen this picture is of stainless steel type of pressure vessel material being used, and the limpet parameter is being welded out peripherally outside. Now moving to the design parameters of this particular project that will be discussed in the second part of this particular presentation.